So today we have a text file that has a little haiku in it, and we want to build a file reader application on the CLI that prints the haiku to the command line. If we try and run the application at the moment, it'll just say hello world because that's the only function that we have inside the main function. So the first thing we're going to have to do is get the arguments, and when I'm learning, I don't like the AI autocomplete, so I'm going to turn this on to subtle, and that means that I now have to figure out what the arguments are. They're going to be a vector of strings, since it's a command line, so we're typing into the command line, and that's going to require the standard library. There's the environment package, so that we can grab the arguments and then collect them. So take all the arguments and put them into this variable. There we go. Now we can just use standard env so that we don't have to import it. Perfect. And then I think I'm missing args, and that needs to be capital. So then let's print args. And why won't it let me do that? Format argument must be a string literal. And what's the, okay. Yes, that's, you print by, can I just do that though? No, I have to do that because there are many, it's not a string literal, it's a vector. So I want to print all of the contents of the vector, and I will go cargo run. And the first argument is target debug day 14 file reader. So if I say cargo run xxx, then the first argument is the path to the application, and the second argument is xxx. And if I go xxx then first argument, second argument, third argument. So anything I append to cargo run becomes the second argument in the args variable. So if args.length is less than 2, then I want to throw an error. So let's say eprint line usage would be cargo run and then file underscore path. And then return that. So now if I go cargo run, let's put that after the check. Usage, cargo run, perfect. So now it's throwing an error. But it's not throwing an error, it's telling me that I need to use it in a specific way. So let's say that the file path is So let file path, and this is the path to the file that we want to read. So haiku text is equal to a reference to the argument variable, and I want the second item in the array, so index 1 as opposed to index 0. And it has to be a reference because I want to be able to work with this later, and if I reassign it, then it disappears. So let file becomes I want to actually read the file at that file path using the standard file read function, the standard library's file read crate, I guess, trait. So the file would be, so I want to match it, because if the file doesn't exist, it needs to be able to handle that. So std fs for file system, and then file is the trait I want to use. I believe it's a trait. And then that has a trait on it called open. I'm not sure if this is called a trait. Is it called a trait? An object. And then this is, yeah, I'm not sure which one's the trait and which one's, anyway, it has a thing, and there's an open method on it. And the open method can then open the file path. And I don't need to reference it, because if it disappears at this point, I don't care, because I don't need the file path. I just want the actual contents of the file. So if it's fine, then I get a file. Actually, I'm already calling file here, so let's just call it f. And if there's an error, then, oh, didn't make that a file error. If there's an error, then I want to eprint line fail to read file, and then give it the file. Oh no, pass in the error, fail to read file, and then whatever the error is, and then return that. Now this file is an unused variable, so let's try and just print the file out directly and see what we get. I doubt this is going to work, because it's probably going to be in a strange format, but let's just see. So the file path would be src haiku.txt. So we get the file, and it's fd path read true, write false. So that's a bunch of metadata, not the actual file contents itself. So we want to read the file contents, so we create a reader, and that reader uses standard IO, I learned this, buff reader. So let's go buff reader, and then new file. So buff reader is a struct that adds buffering, which makes it easier to read files rather than by bits of information, by like chunks of information. And it improves the speed of repeated read calls. I don't know if it's possible to do this without buffreader, but well, let's see if it's possible to do it without the buffreader. So let's say for lines in file, for every line in the file, but there are no lines in the file because it's a file, like good text, read true. Yeah, like there's no way for me to access this, so I have to go for the lines in the reader. And then enumerate over them. And there's no method found on the buffreader that allows me to get the lines function. So I need to import this. Let's say use, so then I can just use buffreader. And then in addition to buffreader, I need this thing called buffread. And as you can see, once I bring this into the file with the use, then suddenly I have access to lines on the reader. So now lines is a variable that has a number and a result. So let's destructure this and say I just want the line, not the line number. So we can skip the first bit and just destructure the second bit. And then I want to enumerate over that and say let line is equal to line.unwrap. And then print the line as a macro, which would take some curly braces, and then I want to pass in the line at the curly braces. And then I can delete this. And we should be able to get the haiku. Yes, memory save, no seg faults, compile time brings peace. Oh, borrow jack of cards. Fantastic, that's what I wanted. Now, this introduces the standard environment variable, which we've seen before, and the buffreader and buffread. And also there's the standard fs file, which we can extract out here so that we can just say file read. And that should all still work. Perfect. Now let's try and show the actual lines. Let's use this and show the actual lines as well. So we want to add a option to the end here that says dash dash lines. And if you add that argument, then it should give you the number of lines in the file as well. So let's create another variable called show lines. that would be a Boolean of whether or not the argument variables contains the line string. Like, does the arguments variable say dash dash lines to underscore string? And then let's just print that out. Since it's not a string literal, we have to go boom, boom. Okay, so now cargo run, and it says false here. But if we say, here, actually, let's just run that again. This time say dash dash lines. And now it says true. So that's the first variable, and then this is the second print line that we're doing at the end. Okay. So now that I have a Boolean that tells me if I want to print the lines out, let's use this line number and say if show lines, then print something, and then otherwise, if there isn't the show line, print something else. So what I want to print here is the actual line number plus 1, since it's index based, and then the line. So let's try that. Line 1, line 2, line 3. Perfect. The last thing we can implement here is a search function. Yeah, so we're going to go with the search function. So basically, let's do the same thing again, and let's add another argument for dash dash search, and then put the keyword that we want to search for. So then we have to say, look, the keyword would be the args. So you want to iterate through the arguments and then see if there is a value of x where x is equal to dash dash search. And the reason we want to do this is because we may not use lines. We may just go cargo run search. So it can't always be I can't just check for contains because I need to actually get the position of it if we don't use lines. Like it won't always be the third argument. So if there is search in the argument variables, then I want to get the position. Plus 1 because of the index spacing. But let's create, we don't have the position, so let's call this the position. Let's say let some position equal and if we're using sum, it's an if-then statement. So if there's a position, then create a variable out of it. Otherwise, say that there is none. So let's print that out. And let's put the keyword there. Sorry, this position plus 1 is not because of index 0 index numbering. It's because the keyword will be whatever the position of search is plus 1, like the next item along. So let's try that. So let's say haiku lines, but this time let's say search for guards. And there is a search. It's getting confusing because I'm keeping all my print lines in there. So let's do that again. The output is some guards. So it said that there is a search string in the arguments, and then it returned that value plus 1, which is the value of guards. And if we do this again, and we just say haiku, then we get none. So there's no search term. And if we do this, and we have search, but we also have lines, then we still manage to catch it. And if we do it the other way around, and we put lines at the very end, it still manages to catch it. So it doesn't really matter where we put the search argument. So now I guess we should say, look, if you found the keyword, then map it and whatever the keyword is, give me the line that contains the keyword. And then only show me the lines or the haiku if the keyword exists. So if I say search lines, guards, all of that, it's saying this show lines doesn't need to exist, the parentheses around it, fair. And it's only returning borrow checker guards. So it only returns the line with that word. So if I just go print out the haiku, then it gives me the haiku. If I say print out the haiku with line numbers, it gives me line numbers. And then if I print out line numbers with a search term, and the search term is piece, then it just gives me the line with that keyword. Fantastic. That's it.